Section 7.2, Sum and Difference Formulas. Before we begin, we need to note two things. Over on the right-hand side, you see that we have sine of 30 plus sine of 60. Well, this equals, from the unit circle, the sine of 30, which is 1/2, and sine of 60 from the unit circle is root 3 over 2. So this whole thing equals 1 plus root 3 over 2. However, if we were to write it where we're taking the sine of 30 plus 60, then we could simplify it into sine of 90 degrees, which from the unit circle equals 1. The thing to note with this, or these two examples, is that these are not the same thing. So in example 1, we need to find the exact value of sine of 15 degrees. Well, sine of 15 degrees, the exact value doesn't exist on the unit circle. So we're going to write 15 in terms of 45 and 30. And I'll show you what I mean in one sec. The important thing to note is that to get 15, there could be a couple of possibilities. So just because you're going to write down what I have today doesn't mean that that's the only option. It's just the one that I'm choosing to do. So I know that the sine of 15 degrees is also equal to the sine of 45 degrees minus 30 degrees. And the reason why I split it like this is because I'm going to use the difference formula for sine. And this is what it says. Sine of alpha minus beta equals the sine of alpha times cosine beta minus cosine alpha sine beta. So what we just created is the difference formula for sine. And this will be given to you on that formula sheet that you've already gotten. So now we're going to replace alpha and beta with our 45 and 30. So we're going to have, this is equal to sine of 45 degrees times cosine of 30 degrees minus cosine of 45 degrees times sine of 30 degrees. And we're going to use our unit circle and come up with the values. Square root of 2 over 2 is sine of 45 times cosine of 30, which is root 3 over 2. And then we're going to subtract root 2 over 2 times 1/2. Again, all from the unit circle. And this all equals root 6 minus root 2 all over 4. For number 2, we need to come up with cosine of 165. So the two values that I think of to get 165 are 135 and 30. So I can say that the cosine of 165 degrees is equal to the cosine of 135 degrees plus 30. So remember, the two values that you're adding or subtracting to give you your the value of your problem, the 165, those are values that are on the unit circle. So we're not just making these up. 135 and 30 both have a place on the unit circle. So if I'm adding with cosine, that formula looks like this. Cosine of alpha plus beta equals cosine of alpha times cosine of beta minus, note that with cosine we're going to have opposites, sine of alpha sine of beta. So this right here is the sum formula for cosine. So if we continue and plug in our values, this is going to equal cosine of 135 times cosine of 30 minus sine of 135 times sine of 30. And from the unit circle, each of those values give you root 2 over 2 times root 3 over 2 minus root 2 over 2 times 1/2. And this simplifies into negative root 6 minus root 2 over 4. For number 3, we're going to find the exact value for sine of 285. And what I think of first is that I can make sine of 285 degrees from taking sine of 240 and adding 45 to it. So now we're doing the sum formula for sine. And that looks very similar to our difference, except we have a plus sign in the middle. Sine alpha times cosine beta plus cosine alpha sine beta. So when we substitute our values, we're going to have sine of 285 is equal to sine of 240 cosine of 45, plus cosine of 240 times sine of 45. And from the unit circle, we're going to get negative root 3 over 2 times root 2 over 2 plus negative 1/2 times root 2 over 2. And this simplifies into negative root 6 minus root 2 all over 4. So we're going to get values and solutions that are very similar looking because all the values on the unit circle, all the terminal points have a denominator of 2. And other than that, we have 1/2 root 3 over 2 and root 2 over 2. So if we keep using the same values, our solutions are going to look very similar. We just have to watch the signs. Okay, and our last one, cosine of 75. So when I think of the cosine of 75 degrees, I'm going to say that that is equal to cosine of 135 degrees minus 60 degrees. And again, you might think of something else. However, the point of my first 4 examples are to give you an example of the sum and difference for each sine and cosine. But when we continue through with the practice examples, you might think of something else, and that's going to give you your same answer as long as you do it correctly. So when we are doing, now we're doing a difference for cosine. So we have cosine alpha minus beta equals cosine alpha cosine beta plus, because it's opposite with sine alpha sine beta. Okay, so this means we are going to have cosine of 75 is equal to cosine of 135 times cosine of 60 plus sine of 135 times sine of 60. And from our unit circle, we're going to get negative root 2 over 2 times 1/2 plus root 2 over 2 times root 3 over 2. So our final answer is going to be negative root 2 plus root 6 all over 4. Now we're going to use the same formulas, but we're going to work with radian values. So when I think of cosine of 17 pi over 12, I think of 8 plus 9. So I'll show you what I mean. So cosine of 17 pi over 12 is also equal to cosine of 8 plus 9 pi over 12. So when I simplify 8 plus 9, 8 over 12 and 9 over 12, I get cosine of 2 pi over 3, which is on the unit circle, plus 3 pi over 4, which is also on the unit circle. So I just created a sum of the sum formula for cosine. So when I use this, I'm going to have cosine of 2 pi over 3 times cosine of 3 pi over 4. Minus sine of 2 pi over 3 times sine of 3 pi over 4. And so again, we need to look up the values on the unit circle, and we get negative 1/2 times negative root 2 over 2 minus root 3 over 2 times root 2 over 2. And this is equal to root 2 minus root 6 over 4. Okay, so for the exact value of sine of 5 pi over 12, so you can do, I'm going to do 8 minus 3. Yes, you could do 2 and 3. Both are divisible by 12, and then you'd have pi over 6 and pi over 4, which are on the unit circle. So that works too. So moving forward, we have 2 pi over 3, because 8 over 12 simplifies to 2/3, minus pi over 4, because you have 3 over 12. So my formula is going to be sine of 2 pi over 3 times cosine of pi over 4 minus cosine of 2 pi over 3 times sine of pi over 4. And from the unit circle, we get root 3 over 2 times root 2 over 2, subtract negative 1/2 times root 2 over 2. And this gives us root 6 plus root 2 all over root 4. Okay, so for the next one, we have negative 5 pi over 12. So I'm going to do something very similar, except I'm going to use sine. I'm going to switch the problem around and just write it as sine of 3 minus 8 pi over 12. So we have sine of pi over 4 minus 2 pi over 3. So very similar. So we're going to have sine of pi over 4, cosine of 2 pi over 3, minus cosine of pi over 4 times sine of 2 pi over 3. And the unit circle gives us root 2 over 2 times negative 1/2 minus root 2 over 2 times root 3 over 2. And this simplifies to the opposite of number 6, because we just switched the 3 and the 5 around. Oh, I'm sorry, the 8 and the 3 around. So we're going to have negative root 2 minus root 6 all over 4. This also follows the fact that sine has odd symmetry. So the two inputs and outputs support that identity as well. Okay, so for 7 pi over 12, I'm going to do 3 and 4. So this gives us cosine of pi over 4 minus pi over 3. So this is the sum formula. And I just made that, it's pi over 4 plus pi over 3. Sorry about that. Okay, so we're going to have cosine of pi over 4, cosine of pi over 3, subtract, because it's opposite with cosine, sine of pi over 4 times sine of pi over 3. From the unit circle, we get root 2 over 2 times 1/2 minus root 2 over 2 times root 3 over 2. And when we multiply across, we get root 2 minus root 6 all over 4.